All right, well, welcome. What we're going to do is we're going to go through an AP pre-response question, and this should help you out to hopefully understand how to do the exam, and also hopefully kind of put everything together um, for derivatives and integrals, which is the two basic fundamental properties of calculus. All right, so without further ado, let's talk about this. Well, in 2013, they have a table problem. Listen to this, and it says, hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t 0 to 6 is given by a differential function c. All right, there is where t is measured in minutes. Select values of c of t measured in ounces are given on the table above. All right, so we're going to go through this step by step. I'm going to make two videos, first going through A and B, and then we're going to go through C and D. All right, so without further ado, let's check out part A. Well, we can't use our calculator here, and it says use the data in the table to approximate C prime of 3.5. Now 3.5, okay, is right in between 3 and 4. Okay, so t equaling 3.5 is located right in between those two. Whereas to find C prime. Now C prime means we're finding a derivative. Now if you've listened to any calculus carols or whatnot, you know that, I'm going to just change this line to make it a little bit nicer. All right, a derivative means we're finding a rate. All right, or essentially we're finding the slope of the curve at, all right, t equaling 3.5. Now we are estimating this. We are only estimating this. And many of the problems what we're given is a function, and we would take the derivative of that, and then we would plug the values in. Well, in this case, we do not have a function derivative. We have the function c. It's given by a table, and we're asked to approximate 3.5. So to do that, we are simply going to find the slope. So we're going to write this out saying 3.5, all right, is going to be approximating, all right, and we're going to go here. We're going to say, okay, we're going to use C of 4, and then we're going to subtract that from C of 3 because, once again, we're asked to find the slope of the curve, and we're going to go for minus 3. Okay, 4 minus 3. Now from here, that will give us a good approximation of what 3.5 will be because it's right in the middle of 3 and 4. So now we're going to, all right, show our computation. So we show our computation. We're going to plug in our values. So now we have 12.8 minus 11.2, and that's going to be divided by 1. And then we're going to simplify this a little bit more. And what we have then right here is going to equal 1.6. We have to make sure we indicate our units of measure. And since it's a slope, we have C, which is ounces, all right, per minute, ounces per minute. And if you can't see that, that would be ounces per minute. We could write it like that. Okay, and that is our answer, 1.5 ounces per minute. Cool, and that's how we do it. All right, given a derivative, we're finding a slope, and we do the best to approximate it in that way. All right, make sure you use little approximation symbols when you're doing so. All right, just to show that this right here, we are approximating 3.5. All right, so continuing on, we can go down to part B. And it says, is there a time t from 3 to 4 at which C prime equals 2? Well, if there's is there a value from C prime equaling 2 justifying answer? Well, this is saying, is there going to be a slope, all right, a rate of ounces per minute that are going to equal 2, because that's what C prime is from 2 to 4. Well, this looks like a value theorem. We see that we have C because this says is going right here. It says it's differentiable, so we know that C is continuous. All right, so C, all right, or C of t is continuous on the interval, okay, from 0 to 6. So we know that's going to be true. Okay, because since it's continuous, we also know it's differentiable. All right, continuous and differentiable, and that is good to know. Okay, we also know we have a closed interval. Open interval there. All right, we also have a closed interval where this is closed from 2 to 4. Now, because we have these two things, we are looking at a value theorem that we probably could use. all right, a value theorem. And that is generally always on the AP test. Sometimes you can use intermediate value theorem and whatnot. But because they're saying that C prime of t is saying that the slope of C is going to equal 2, this looks like the mean value theorem of differentiation. And what does the mean value theorem state? Well, in order for this to be true, we have to prove that the average values, so that means from 4 to 2, so if you found C of 4 minus C of 2 over 4 minus 2, if we found that, and if that equaled 2, all right, if that equaled 2, then we know that yes, there is a value there. Okay, so we're just going to go through here and just verify this. We can use the mean value theorem because it's continuous and differentiable and closed on this interval. The mean value states that this would have to be true if this were true. And so we're going to just go over here and see what that would be. So C of 4 is going to be 12 point. All right, so finding our average slope, all right, minus C of 2 is going to be right there, which is 8.8, and we're dividing that by 2. All right, take those right there. You realize you have 4 divided by 2, which, what do you know? It equals 2. So because the average value equals 2, and because this is differentiable, we know that, yes, is there a time? Yes. All right. Yes, there is a time. All right, where, all right, C prime of t will equal 2 because of the mean value theorem, and we could go to MVT. We showed our work that proves it out, and there we have it. Okay, we know we can use the mean value theorem once again because it's continuous, closed, and differentiable, and that's what we have there. So that's our answer. Okay, and so when you're given something like this, and they ask us to justify, they're asking you, is there such a time that's an existence theorem, and it's probably going to be mean value or mean value theorem than that. How do we know it's a mean value? Because it's derivative equals a value, and so we find the average slope equals the instantaneous slope, hopefully that too. Okay, all right, well, I'm going to stop it here and do the final two in my next video.